Hello? 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 Let's start now. So I had one announcement, it's already in the backpack, but I still want to tell you one thing that those who have taken the advanced mobile computing course, it's a 700 level course here, they are not allowed to take this course. And the reason is obvious. That once you've taken an advanced version of this course, right, you can't then come and take this course. You already have an added advantage there. Right? And so I hope there is nobody who has taken this course here. Your first assignment is online. It's very simple assignment. It's posted there, but we will start with few basic concepts today. And because I realize there is big difference. Being a big class, there is also big difference in terms of the knowledge of Android and mobile programming here. Some of you, just like when you joined the BTech course here, some of you already knew programming and some of you didn't know. Same thing, there are some of you who already know Android programming reasonably well. But there are some of you who have no idea, no clue about what Android programming is. So I will start with basics. And these basics is something those who already know programming cannot ignore also. The reason being, I am not going to give you the actual coding examples here in the class. I will talk about the concepts which are cutting across not just Android but multiple other platforms. They are applicable there also. Even within Android, I will talk about concepts which should take you from one version of Android to another version of Android very easy. Right? So you will know lots of syntax, but after this course, hopefully you will know the reason why this syntax is there and what you're supposed to do and when it is right to use that API. Okay? So it's more than just programming. I hope you will realize after this. Alright, so let's start. So I'm going to have my own slides also, and I will then also jump, if I have time today, to the slides from Coursera, because there are some things which are explained nicely there, and I would like to borrow those from Coursera and also show it to you. We are not posting the slides from Coursera online on Backpack because there will be copyright issues. Right? So we can't post everything there, but Nikita is posting the links and how to find those slides. So I hope you go and look at those slides. Okay, so the title of today's topic or lecture is Smartphone and Android. I will first talk about what a smartphone is and how we landed up into this. What is an advantage of having a smartphone? And then we will go to a specific case of Android in terms of smartphone. Okay. So this is like I have a habit of referring to the very beginning of everything, and this is right, the first mobile phone, right? And it's big because it's actually heavier normally than a brain, right? It's about 1.1 kg, right? And you see it's pretty big. It has its own antenna. And even today's cordless phone is probably lighter and slimmer and more efficient in terms of battery as compared to this one, right? And just the other side. So the first company that came up with this is Motorola, and then again today you're seeing lots of phones from Motorola. In the meantime, sometime in between it was lost. If you see iPhone, it's about $700, and this was costing 4,000 when it started, right? So you see iPhone was still cheaper, right, compared to what it was when we started with mobile phone, right? The charges were really exorbitant, hefty, right? Nobody really could afford a mobile phone and pay the bill, right? For example, if you are in the roaming, you could actually go bankrupt, right? It's so expensive. On top of that, the coverage was also not so good. Very important for our lecture is it's a closed model. I will explain more about this in today's slide. It's a very closed model. That means one manufacturer, he designs his operating system, like you own the phone and the hardware, but basically you can't do anything with that. Right? It's still a property and intellectual property of that other company, and you can only use the things that company wants you to use. That's it. You can't put anything on top of that. Right? So that's the closed model. Phones are fully designed and developed by manufacturers, and they develop the operating system and they develop the apps and everything together. Right? Competition between the companies. So first was Motorola, and then the other companies came into this. Competition was really fierce, and there are lots of things in terms of hardware and software that were trade secrets. Right? And because of that, it also became a closed model. Phone software was developed by the company itself, right, who may not necessarily be very good in terms of opening up the system and making it compatible with everything. Right? So we started from this. Then came the internet, and this was only voice. Then came the internet, and we had lots of very good websites with text, images, and all sorts of media, video, audio, right? Very highly enriched. The technology on the web is evolving very fast. You had JavaScript, then Flash, then Ajax, you did not mention everything, right? And the resolution is better. It was getting better and better, far more than this one. Right? So again, the same company, Motorola, came up with the phone in 96, right? But it still has LCD of only 10 digits, right? And in 96, the web was actually on HTTP platform and streaming the images. Right? So you see now the disparity between the phone world and where the internet is going. There's a big gap between these two. So the phone companies were not able to catch up with it for whatever reason. Right? And it has problems of low resolution, limited storage, limited processing power, and low bandwidth. Right? It had all sorts of challenges from every aspect, and so it could not catch up with the internet world and provide the internet to the user through this phone. Anybody knows what was the solution for this? If you remember, I think you were young at that time, with me. But still, anybody remembers what was in 99 or so? How did you access internet before you started with 2G? Or when you started with 2G? Dial-up was one on the phone. I'm talking about the mobile phone. You couldn't see HTTP. You saw something else. Back. Very good. You said back. Okay. Right, so that was it. Right, so every engineer's solution, right? Just make your solution, right? Do something so that it works. You got solution. Right? You can't make it really work efficiently end-to-end. If it somehow, right, that it works. And this is what they came up with, wireless application protocol. They couldn't get the HTTP on the phone. So they say, okay, let's do something else. So they took out lots of nice features of HTTP And what finally remains is WAP. And they could then implement a browser of WAP on a phone. So if you go to 90s phone, the late 90s phones, they could show you web browsers. Right? And they could show you it requires less memory, less bandwidth, so that was all good. Right? But then it came up with its own markup language called WMS, WAP markup language, which is different from HTML. Right? So every site that you want to now see on the phone has to have another website corresponding. One is HTML, which is using HTTP protocol and which you can see on your laptops and desktops. But then you also write the same site in a different markup language, which is compatible with that. Right? Now imagine this, that every website has duplicate copies. You replicate everything there, here and there. Right? So that was a big thing because not many websites were map enabled, and so you cannot access that much of content on the phone because there is nothing on the phone to watch for. Why would everybody rewrite his own website or another markup language? So content providers often didn't bother with the website. They say, okay, let's forget website. I'm just having a HTTP website, and then whatever you want to communicate with me, I will just send you SMS. So you send me an SMS, I will reply back with an SMS, which was expensive. Still today it is expensive, but people do it, right? Because like, who's going to rewrite the whole website in a different language, right? So anybody now remembers what happened after this? It survived this thing, even though it's so bad, it survived surprisingly for a very long time. Right? And then who changed the game? In 2006. Apple iPhone, right? First time, if you go to Steve Jobs, I think, announcement speech or declaration speech where he introduced iPhone, he said, you don't have to internet now. There is no internet HTTP and there is no internet for that. We are merging it together. Right? So that's where for the first time he could come up with a device which we now call a smartphone. Right? We merge these two words together. So now we don't have to have that. You can use the same phone, it understands HTTP, it has a very good browser in it. Right? It can talk to the HTTP website. Its version is still not that good. Right? But you don't have to develop two websites. Right? So that's what we say device convergence. Right? Now everything is converged. So whatever advantages you had using JavaScript, Ajax, Flash, videos, everything, right? You can do the same thing equally well on a phone. And these are, so this is advanced in memory backend OS. We will see each one of these, even in networks. I missed out the networks part in it. It's very good in doing lots of networks. It has got, so there are different platforms. One is Palm OS, which is now, I don't think, so this is by HP, I think, but now it's no more. Then BlackBerry OS is still there. J2ME was the first one, and it's still surviving with the Symbian phones. Then Qualcomm with its own operating system, it's not very famous. Symbian OS is this one. And then iOS, it was initially Apple iPhone OS, but now it has iOS, and of course Android. And I missed out Android here. Right, so this was the convergence of everything together. So now we are in the model which I say, or which everybody now says, the internet model. And this is the reason network was successful. I mean, those who have taken the network course here, they know what the internet model is. And it became so successful because of this model. It's not by fluke. And because, right, and we borrowed the same model into the whole world now. And now if you see after 8 years from 2006, this is also very successful, right? And that model is, it gives freedoms to the user to choose lots of things. It gives freedoms to choose your own brand, your own operating system, your ISP, your browser, right? It looks very simple, but the power that comes with this freedom, it's enormous. So you can now choose the combination of all of these, and you can get connected to the internet. Right? There is no restriction on any one of these. Apple lacked something here. What was it? So if you look at Apple's model, it's not full-free. It gives you a platform hardware, right? And on that hardware, you can only run their operating system, right? So that's where they break that model first. So it's not fully the internet model. You buy this hardware and then you can only run this one. You cannot run somebody else's one. Okay? It's not true with what we see as an Android. So if you buy a HTC handset, right, if you want to put the Windows operating system on it, you can do that. If you want to put Android operating system on it, you can do that. It gives you that freedom. So it's more free as compared to Apple's model. Right? And then you can choose your own apps, which Apple allows you in some sense, but not fully. And then you can have freeware, shareware, paid software, everything. Right? And with this, you get that freedom where lots of innovations are possible. Questions on this so far? Is this okay? This might sound very simple, but I guess everything that will come later on. Today we have now tablets. Now very soon we will have wearables. Lots of these smartwatches are already there. They are also following the same model. You just buy the hardware, you put your own operating system, and you can download your whatever apps you want onto that watch, right? And browser and everything, right? And that will create innovation. Right? So Apple has its own Open Handset Alliance, OHA. It was formed in 2007. It combined brought together lots of chip manufacturers, handset, software developers, service providers, everybody together, right? And they called the platform which emerged out of it as Android. So they said, okay, we will be open, we will share our software across each other, we will be open about the hardware specifications, right? And then we will ship the first handset that was shipped. It's called T-Mobile G1. T-Mobile was a service provider. G1 was the model name, and it was developed by HTC, right? And it was released in 2008. That's when the first Android phone came out. And then you are seeing a lot of it. So this is the difference between Android model and the other ones. Android, as compared to the other models, it gives you the maximum freedom. So some of the very important features of this alliance is, right, you can have third-party software developers which will write applications which you will also do. As part of your project, you will develop applications and you will be third-party. I will introduce the terms more carefully and define what third-party is and so on. But as you will become a third-party developer, you will develop the applications, right, and you get the same permissions or capabilities as the default application of the Android. So that means you can replace the browser and put your own browser. You can replace the file manager of Android and put your own file manager. You can even replace the phone, the calling application, and put your own application. Right? So that's the maximum freedom you can ask for. Right? And then you will compete with the same people. And if your product is better, right, people will start using your app as compared to even what is provided by Android. Okay, provided you write a better app. Right, so in Android, there is no distinction between the native Android app and app developed by a third-party application developer is you. And it creates a healthy competition. Right? So that's where you will see the maximum innovation happening, because what you cover today, it can replace everything else in Android. So a quick diagram of how the platform looks like, and then I will talk about this in detail in terms of operating system, how it is done. So far, in terms of very high level, in terms of the freedom model, open alliance, and open system. But for an engineer point of view, this is how it looks like. The physical hardware at the bottom, right? Then I don't think you can read at the back, but what's happening here is there is memory management, there is program management, there is network stack, there is I/O, power management, and other Wi-Fi Bluetooth services. So all these services are part of Linux 2.6 operating system. So this was a slide where application that you will write will be one of these, sitting on top of operating system. So you will not become an operating system. You will not have that permissions. You will not have the root permissions. To be very specific, you will be in the user space. And another thing is your app will run inside a virtual machine. So if you see, I mean, you hear about virtual machine, virtual computing a lot. It's already there on Android. Every app that is running on your phone is running inside its own virtual machine. Now, how is it different from Java? All of you know Java. I want this answer from you now. Java also uses virtual machine. What is the key difference from what I am showing here and what Java does? Slower CPU. That's true. But forget about the solving part. Just the fact that there is a virtual machine in Java and there is this virtual machine here in Android. What is the key difference that you see? That's also true, but it's a little more advanced than what I was expecting. Yes, there is a difference between compilation. Right? Anybody? Yes. Right. Interactive. So that's what you was also saying about the compilation. Okay, but let's look at this. When you execute Java application, how many virtual machines are there on your laptop? One. Right? You start your Java program with one virtual machine sitting, which is giving one layer across here for all the applications on top of it. Right? So all your 10 even Java applications that you're running, they are part of the same Java virtual machine, one virtual machine. Difference in Android is every app, if you have 100 apps and all of them are running, they are running in a separate, isolated virtual machine. And that's a very important difference. Android decided to go on this route. Now, what is the obvious advantage of it? But there also you have multiple projects. Sandboxing. One thing is security-wise, your app is one virtual machine, the other app is another virtual machine. There's no way they can interact easily within a virtual machine. Second thing is, if the app crashes and in Java and it crashes so badly that it takes down the virtual machine, what happens? The other apps which are right, it's not their fault, but they have to also go down because their virtual machine went down. But in Android, if this app crashes on your phone, right, other apps will be working fine. Right? And that gives you robustness. On Android, if one app crashes, right, you start that app again. You don't have to restart all the other apps. They are working fine. Right? So they learn something from Java and they use it here, which is the concept of virtual machine. It gives you all the advantages of virtual machine. So I will not talk about that. But the difference between this and Java is now everybody is in a different virtual machine. And operating system wise, every virtual machine is a different legacy user. When you run a Java program and your own user ID, it's just one user ID. Right? And your app will share the permission of that user ID. And here, every app is different user with different permissions, probably. Right? And that also gives freedom also in terms of giving permissions to every user. Right? So this is key difference between the desktop or enterprise Java and the Java on a smartphone or a mobile device. This one. Okay. Any questions? It depends on, so we will see that. Very slowly we will see that what it can support and how. But it will get limited by amount of memory that you have. And if you don't have that much of RAM and you start so many applications that they cannot fit, right? It will. But that's also a problem for a standard operating system, right? If you see, you start too many programs and you start doing the multiprocessing, multitasking at that time, right, the machine slows down, right? And so we have a solution for that, and we will use the same solution here. We can different way, but that is the same solution Android operating system will also. And it will be then limited by all of your RAM. Right. So then there is a concept of rooting the phone, becoming the super user and doing something. Right? Typically an application by default, right, doesn't get any permissions, very few permissions. And with that it doesn't have capability of modifying or changing anything at the OS or system file. Right? But there are ways to surpass that security, right? But then you take the risk. Yes. Right. Yes. Right. Yes. That has more permission. Right. So that's a different app. Right. So every app has got its different sets of permission. One could be to just do anything, and one could do as much as changing the setting inside a phone. And we permission model and what permissions you get as an app developer. Overall, if you want to take a lesson from this, the app will be more successful if asking for less permission and not vice versa. If the app starts asking lots of permissions, I want this also, that capability also, the user will not be inclined to download and install that app. Obviously. So permission is first. So permissions are examples are making a phone call, sending SMS, accessing network and internet. All of this, if you see, they incur monetary charges. If you allow an app to send SMS and it sends SMS to all the foreign numbers or premium numbers, and you see the bill. Right? So if you ask as an app that I want permission to send SMS, it doesn't really ask whether you allow it to send local or STD or international. Right? You just give that permission. And now the app can actually just keep sending it. Lots of security attacks also do it to these things. Same thing with phone calls, same thing with accessing 2G, 3G, and so on. Okay. So we will see this in more detail. I just want to get you started with the Android operating system and smartphone, and then we will go in detail. So first thing you should know is Java programming language for Android. Right? Anybody who doesn't know Java yet? Really? So you are an MTech student. We have never used Java anywhere. Okay, maybe after the class let's talk. Let me understand it. So you should know Java because I am not going to teach Java here. What I will teach you about the differences between Java that you know enterprise or desktop Java and this Java, right? I will only give you the differences. You should know the basic or the base, and then with differences you know Android. Okay, operating system is now supports all these. I will encourage all of you. There are different IDEs available, but Eclipse is the easiest one, right? Because it comes with the Java support, right? So I would recommend that. But those of you who are right who want to take a risk and try out latest things, there are other IDEs available, and you can try it out. Very quickly, I'm not going to go in these details because you are all exposed to this. You get probably the latest version of Java, at least this one. Right? If you see the new compiler for Java, again for those who are in the systems who want to change the default thing, this one is not compatible. GC, when this compiler is not compatible with Android, right? First thing is to get the Eclipse, use the latest one, or at least this one. Then you get Eclipse with Java Enterprise Edition, and you install Android SDK on top of that. So SDK is what? Software development kit. So it gives you the library that Android uses. And you get all these libraries. You install that, and you update your path if need be in the Android tools directory, and then you install Android plugin for Eclipse, which is ADT. Right? With all this, you get the development environment up and ready. So for your first assignment, you have to do all these things, get it ready so that you can write your first application. Okay? And if you have questions, you can post it on Backpack in discussions, right? I can imagine maybe some of you get into a running problem. So post it on Backpack so that maybe somebody else is already resolved it. He or she can answer you very quickly. Okay, so now I will introduce you the tool. You will use the only first one for now. These two are advanced tools. Probably you will use them later for assignments and for your project. But I will just talk about this at a very basic level. So first thing is Android emulator. Not all of you have, or not all of you have an Android phone, right? So to surpass that issue, if your computer can actually behave like an Android phone, what we say in the emulation mode. So you write your code on the phone, on the computer, right? And then you can run it as an Android emulator. You will see the option there on top in Eclipse. Right? It's a generic Android device not tied to any specific phone configuration. You can change some parameters, but at this step, I don't recommend that. Right? You start as a basic Android, right? And then you run your Hello World application or your first assignment on top of that. And you see something like this. It's a little slow, right? But I think it can still give you a flavor of what Android programming is. Yes, if you have a phone, I would recommend running it on the phone directly. And I haven't given the steps to do that. You can find it out. It's not hard. But otherwise, if you don't have it, you can install it as an emulator and run it. Hello. Another one is a debugging monitoring service, DDMS. If you run by chance, like because of your some mistake into issues on the first assignment itself, there is a debug monitoring service which you can use called DDMS. It gives you direct access to the phone emulator and you can start debugging. For example, you can see the process is there, right? You can look at heap data and all of that. But I hope for the Hello World, I don't think we will run into so complex issues. So don't worry about this. This is another way of debugging it on the phone. What we say Android debug bridge. So if you download your app on the phone, run it there, but it runs into some issues. You can connect your phone here, and then your phone can give you the same information here from your phone via USB. Right? So that's another way of debugging. So these are just two debugging tools. I would recommend familiarize with this, but it's not required so far. Okay. So, to summarize what I have said in my slides, right, Android has emerged as a mobile open platform. Right, it has learned a lot from all the old platforms. Like the process part, the CPU, the Java, virtual machine, the security issues about permissions for any users. Has learned a lot from other operating systems. Of course, iOS, the success of iOS. And it has learned all of that. And then it decided to take a path where it is an open system. Right? So no upfront fees also. For example, on iOS, if you want to develop, you have to pay charges. You have to pay annual subscription of $1,500. So by the way, as a student, those of you who are interested in developing iOS, we have a free account. Right? So if you want that, I can give you access to that. Otherwise, Android by default is free for everyone. Right? You are open to choose your hardware, Android version. You write your app, you can compete with the default apps even with the Android operating system. Right? And you can get as many permissions as you want. And then write a very powerful app. Right? And it's possible because of the smartphone. So smartphone it's not a technical job. Technically, the thing that it made successful is that open system, right, and the innovations that we saw in Java. Questions on this? So after this, I will jump into the Coursera slides. So there are very nice slides there as well, right, which is very similar to what I mentioned here. Topics are same. Questions? already seen the video. Okay. So I have a quiz at the end of this, right? The same Socrates quiz. Let's see. I mean, if you can answer the question. I see lots of errors, which is unusual. And nobody really looks at what needs to be done before coming to the class. So we'll check. So these are slides from Coursera. This course is got over in, I think, it was offered in about March time frame. So it starts with Android, right? We are not talking about other operating systems, just directly Android. Right? So what is Android as a system, as an operating system? Right? So it comes with OS kernel. Operating system typically gets divided like I showed in my slide. There is something which is sitting as part of the kernel, system libraries and so on. Right? OS kernel, system libraries, and then something which sits on top is the application framework, and on top of that you have some key applications like your messaging or your calling, your contact book, or your phone book, or your first browser, which probably a Chrome. Right? Then it comes with its own SDK, so that if as a developer you want to develop that, it gives you libraries and it gives you development tools, the tools that I showed you, right? And of course lots of documentation. So all of that is the Android ecosystem. And this is a website you can go and look at it for getting more information. Okay. Now this is how it looks like. And this is where your knowledge of operating system codes and network codes get combined. Right? So this is the Linux kernel. This is what we see the libraries on top of operating system. So those who have played with the Linux operating system or Unix or its flavors, right, they will identify this structure. Right? It's similar to that. And then on top of that, you will see application framework and then application. Right? This is common, no matter what operating system you will now see. Every state of the art latest operating system follows the same thing. Right? So no matter where you jump now and land up in, if you know this structure, you can see what it is running. Can anybody tell me what is the library? What I say is the system library. Those have taken maybe the administration course, system management course. What is the system library? And of course, everybody else is also free to answer this question. It's right. Different applications will use it, but it's not a guideline. It's a little different. Right. Functions, classes. So if I like what is the answer, the way it works is lots of applications use SSH or secure library. HTTPS uses, SSH uses, and all the secure version of network protocols, FTP and so on. Right? They use something which is a secure way of communication, right? And that bit itself comes with cryptography, like public and private cryptography. So these are common across lots of applications, and you don't want every application to reinvent the wheel and start writing or using their own library of secure communication, SSL communication. Right? So that's what we see SSL. Right? Has anybody seen libc? What is libc typically? Anybody know libc? Where do you include use? How do you write a C program? Typically, what's the first line? Right? Include stdio.h. Then what is it? Where is it sitting? libc. See, if every C program uses stdio.h and you include it, just imagine thousands of apps, everybody including that code in its own code. stdio. Right? And then every app will become so big because everybody is including all the system libraries. Right? So what you do is, this is the library for a compiled version of stdio.h. Right? So at runtime, your app can directly use this one. And it can have all the functions on stdio.h. Doesn't have to reinvent it or write it from scratch. Right? And you have the OpenGL for graphics. Right? And I will told you to tell you about more SQLite. It's a database, so all the applications can use databases. Right? And all of this will become part of library. Right? And this is provided by the operating system to you. Then the bottom part is the Linux kernel, which is running at a privileged mode. So one way of saying what is privileged or where you need privileges is whenever you directly access real hardware, you need authenticated or super user access. Because you don't want any third-party application doing something with your graphics card or network card. It can damage this hardware. Right? If you set the wrong voltages for your screen, right, or the frequency of your screen is wrong, right, it can irreversibly damage the hardware. Right? So that's why you need very specific programs that can do that, and those are super users which can do that. Right? So these are part of the kernel. Right? So for example, if you clock your CPU at a higher rate, it allows you, but if you use continuously, right, it might damage it. Same thing with your hard disk and everything. Right? So these are all Linux kernel processes and systems. Then you have libraries, right? And then you have Android runtime, right, which is the dynamic virtual machine. It's a Java virtual machine with some differences. What she was saying, it's more optimum for a slow processor and less memory. So that's it. Dynamic machine is libraries, and then you have an application framework. This is again on top of OS but below application. So one example of this is telephony manager or location manager these days, GPS and everything, all the locations. So that gives you a consistent access. Every application is Foursquare, Facebook, Google Maps. Everybody is interested in getting your location. Okay. So what you do is you have a location manager here, which will give a consistent view across to everybody. Right? And then you can control who can get access to your location by talking to this manager. If you don't want, because there is a privacy issue involved in it. If you don't want one app to get your location, you can say no for that app. Right? And you get one way of controlling everything and a central point of view is this one. Right? So this is how the whole Android stack. If you see from bottom to top, there is kernel, there are libraries, then there is virtual machine here sitting running on top of your Linux kernel. And then you have application framework, which has lots of components. One example I described is location, right? And then your application. Right? Contacts, phone, browser, these are the default applications which always come with the phone. And then you can write your own application here. Questions on this architecture? What is the difference between these two or what? So this is like a library. If you open any .h file, it gives you lots of function calls. System calls, APIs. Right? So these are APIs. That just gives you access. So for example, if you want to, let's say, print something on the screen, right? The way to do that is called printf in C. But that is implemented in the library. Right? This is application framework is doing far more than just giving you a library. Right? It understands what sort of location methods you have. You have GPS, you have Wi-Fi location, and all of that. You have cell ID based location, cellular location, right? And then who has access to that? Right? So it's not a library. It is managing your location. So it's more like a manager which will use the library. Right? It has its own processing code. This is just, so this will run, right? It has its own logic. This is just a library. If you never call this library, right, you will not use it. Yes. It's some sort of code, yes. Right, which is continuously running and doing and managing things for you. Right? Another example, let me give another example, notification management. You see lots of notifications because of your SMS, your email, Facebook, right, all these notifications. There's only one entity which is handling all these notifications and showing it to you. I will show you the screenshots. Right? So that's a manager. It's not a library. It's a manager which will manage. Right? So some notifications are sticky. They will stick around. Some notifications will just vanish after some time. And if you tap on a notification, you will be taken to an application. And all of these things are defined and handled by the manager. So kernel gives you, like any operating system, kernel gives you security, it gives you process and memory management, it gives you file and network I/O and all the device shares. Right? This is part of OS code, so I will not talk much about it. Right? On top of that, very important thing that portable devices should have is power management, because you have very limited battery power. So how to manage power, right? Share memory, how to share memory across different things. Low memory killer. So one of the questions that one of the students was asking about is how many apps you can open, because everyone has got its own virtual machine. Right? So that's the thing. Low memory killer. And if you run out of memory, what you should do? Right? Android has a very elaborate process on that. Right? And also it should be something that if you're looking at an app, suddenly it should not vanish. Right? If you're running low on the memory, still the app that you're looking at should not go away for whatever reason. Right? So which one to kill and when to bring it back? That inter-process communication. Can you give me an example of inter-process communication? You have used smartphone. You give me an example where. Right. Any other example? So the example that she gave is social media sites. They can look at your contact information. Right? Facebook app can look at your contacts and then put photos accordingly or link it to their Facebook accounts. What is another way of inter-process communication? Knowing the location. Right? So for example, Foursquare can get location, and if you want to know the Google Maps directions, it gets open. Right? For example, that I give you, you tap on a notification, it takes you an app, the corresponding app. That is the inter-process communication. Right? So you see, the options of inter-process communication is very fundamental for a smartphone as compared to a desktop. Desktop typically applications don't talk to each other, right? My Microsoft Office or any document editing software will not typically talk with anybody else. Right? But on the phone, one app is calling another app, then it might call another app, right? And so on. It will continuously happen. So this is important in the kernel and it's Android or smartphone specific, right? So that way it becomes important. So these are the libraries. I'm not going into all the detailed libraries. I explained about SSL. Another library is WebKit. WebKit gives you a rendering engine through HTML files. A lot of databases in the form of HTML, and browsers are the best way to look at HTML because they can render it very nicely. But if your app was forced to render the same thing, then it doesn't have to write an HTTP parser. It can use the library which came with your code, and it will render the whole HTML for you. Right? It's very important. So those of you who take projects and want to show HTML code or HTML pages, don't write your own browser from scratch. And you can use the parser that is there on the phone. It will render it for you in wherever you want to show it. Right? Same thing with OpenGL, like graphics engine. Lots of things you want to develop a game. Right? You don't have to start from scratch and show the objects inside the game. Just use OpenGL and lots of things will be rendered very easily for you. Right? Databases. You don't install your own database and manage it. You use the library which comes SQLite and then put your database there and so on for everything else. Right? So this is all the libraries here. Then the runtime. Two main components, four Java libraries are there as part of this. So you can use Java function calls that you are used to, and then its own Java or Dalvik virtual machine. So the core Java libraries are all java.start, java x.start. Then, and I will talk about lifecycle in detail. And this is a very involved topic in itself. But all these libraries are there. Internet web services, org or something. Unit testing, if you want to do JUnit testing. So that's it. And then apps are executed by the VM. So some of you gave me, when I asked you the question about what is the difference between the Dalvik virtual machine and Java virtual machine, you talked about compilation. So how is this compilation different now? So far what you do is you take Java code or Java file, you compile it, you get .class file. Then you get the Java runtime environment, you execute .class file. Right? So far this is how we have been doing. It's a little different here. What you do is you still write in .java file, right? But what you do is it gets compiled to the Java bytecode, and then it gets converted into the bytecode required for Dalvik virtual machine, and that is called the text file. So you get the Java compile code, and then you call another compiler or converter rather that will convert it to the virtual machine or to the Dalvik virtual machine interpretation. And then you can execute this using Dalvik virtual machine. Right? So there is one more state now added on your laptop itself. Another difference is you don't have a Dalvik virtual machine by default installed on your laptop. Dalvik virtual machine is there on the phone. Right? So far, I don't think anybody of you have done this. You compile the code on a machine, but you don't execute it on that machine. It's a different concept. You compile it on your machine, but you don't execute it. You execute it on a different machine. What is it called? There is a name for this process. Cross compilation. Right? Those who come from maybe W background are aware of this. It's called cross compilation. So you write your code on one machine, you compile it there on that machine, executable that you get is for a different architecture or a different machine. This is called cross compilation. So even though you haven't taken the embedded system course, right, you are not EC or WE student, right, but this is a concept which you can learn from here and you can apply it at different places. Right? So smartphone is basically an embedded system. Right? I give a very nice coaching, or everybody gives a nice coaching of mobile computing into that. Inside it is basically writing code for embedded systems. Phone is in a lot of sense an embedded system, right? And that's why this is the work. You write code, you compile it, and you then convert it to another code which your machine cannot execute. So you transfer it to another machine and you execute it there. If some error happens, you come back to your code, you make changes, you again double compilation or compilation and conversion, and you again transfer the code. Right? So it becomes a little hectic to do programming in this way because you have to always do cross compilation. So Dalvik machine, why we need? If we already had Java, why have another version? So the Java as it is designed mostly for enterprise applications, high-end applications that we have. Right? So they get suited for a mobile phone environment. Right? They make changes into its virtual machine code so that it can run on slower CPU, on lesser RAM, and limited battery life. Right? So this is a big difference between the standard Java and the Java for Android. It is more designed and suited for this. Right? So you can, if you, those of you who want to see more about Dalvik VM, it's a very nice YouTube video. I will put this slide at the end of this lecture today. Right? So you can go, I would recommend all of you to look at this video. Okay, so far we have seen this much. Right? And then the application framework. Right? So it keeps track. So one example was the package manager. You install so many applications. Who is looking at what applications you have? Right? Which applications you have? If you want to uninstall it, who to contact to get it uninstalled? Right? So there should be somebody, some entity will keep track of all the applications and where they are located. So that if you want to remove it, you can delete those files. Right? So I'm showing you the phone, but it is for the recent Android, it looks like this. Right? And then so these are all the applications and right, the package manager knows every application. There is one thing that will manage the entire window for you. Right? And that's what we call a window manager. Typically, it has got this main window. These are sub windows for every application, and there is a notification bar at the top. Applications do not get access to the notification bar very easily, right? Because it's reserved for some important notifications like the time, the battery, the network connections. Right? So that what primarily sits in the notification bar, and then you have a main window and there is lots of sub windows. Right? So don't worry too much about this right now. Just understand what this manager is doing. You will get to know more about how to use this thing later on. It provides you a common interface for all the applications. They don't have to start writing how to manage icons, text boxes, buttons, right? So it's a consistent view across all the applications. If you want to create a button, you use this one, this managing system. So that the button looks similar to everything. For example, the home button, the back button. These are important buttons and they should be consistently what they do about and how they look like in all the applications. The window manager will handle it. Same thing with the tabs. Right? So you can actually click this app icon, so that's why the button. So the resource manager is all about, again, this is a complex topic or a different topic which you don't know. Non-compiled resources. What is a non-compiled resource? Your code is a compiled resource. Like what if you want to change the icon of a program? So you see Foursquare released a new app, new version of an app. They change the icon. What do we do? Where is the icon sitting? Those who know who's done Android programming probably will know this. In separate folders. So it's not coded in the code. It's not hard coded. Right? Even the path to that icon image, it's not hard coded. What happens is there is a separate folder where you keep whatever icon image that you wanted. And now when the Foursquare app is started or it's shown on by the Android phone, it knows where to look for its image. Right? So next time when you want to release or want to change the icon, you don't have to recompile the code. Right? The code stays there. And I just give you one example of the icon. But there are lots of things which you don't want to get hard coded inside the code. But these are the dynamic. Right? So what you do is there is a separate folder where you announce all of that. Right? And there is a resource manager which will handle all these things which is not compiled. It's typically written in the XML format. This is, I will talk in detail little later, activity manager in the next class. Content provider you already talked about, you can share contacts between Facebook and the phone book. Right, so that's location manager I talked about. It gives you location in terms of GPS, Wi-Fi, cellular. Right, it also tells you about your movement these days. If you're walking, if you're running, right, if you're stationary, phone can detect that. And it can tell the application about it if the application wants to know. Notifications, I think you all know. And the apps, and that's also everybody knows because you're looking at the apps for a long time. These are the default home app, home main screen, contacts app, phone book, browser, email reader, right, where you can send and receive messages. Right? So this is how can see the same thing. Nothing special about these apps which comes in the phone. You can substitute your own or third-party app for any one of these. Right? So you can actually replace even the browser with your own browser because you get that capacity here. Right? And that's why this is a powerful environment. So I have shown you Android, why I first talked about the smartphone system. Right? Why we needed a smartphone. What was the difference between the phones that we had before the smartphone era and today's era? Then I talked about how we are evolving in terms of smartphones, going from where to where. And I took a very specific example of Android. I showed you its stack in terms of operating system, libraries, application, and framework. So you know where things sit, which are common and which you can just utilize as it is. Which things you can replace and which things you cannot replace. I talked about the Java that you have learned so far and a big difference between the Java and Android. Then I told you what will be your basic steps to install IDE to develop your own app. Right? And you will do all that and install your first app. Right? Any questions so far on this? Okay, so this is where we stand, right? And now again, if you have listened to the lecture correctly and if you probably have looked at the videos before coming here, you can answer these three questions. So there are three questions, right? What is the room number? The same, PSC 525 monsoon 2014. Let me just write down. So there are three questions. First two are objective questions, multiple choice. Right? You can select one choice or all choices or right and in between. Right? It's not necessarily just one choice. Multiple choices could also be correct. So select whatever is correct, you think. And so the third question is subjective descriptive. So you have to write it down. Write down as much as you do and submit it so that I get an idea about how many of you actually are attending in the class and understand. So do it right now, and if you are done, you can leave. You can leave. Okay, those of you can do it right now. I would really encourage them to do it right now. I understand some of you for some reasons are not able to do it. You can do it later. But I will close this very soon. Right? I don't want this to linger for a long time. It's not working. Okay, so I think today a lot of you are seeing this issue. I think it's very slow. So take your time. Yes, yes, yes. Sure, sure.